Hello everyone, welcome to EdSofta's JAMB tutorial for mathematics. My name is Sam Malukwe. I am the software developer at EdSofta and I'm also engaging in teaching our students. We're also engaging in teaching our users, preparing them for their soon to come JAMB exam. So we the last live we talked about AP and GP. Now we'll be talking about Surds. Now, quick overview of what EdSofta is. EdSofta is an edtech, educational tech company. So we use technology to enhance education. We have an app, and our app has study materials, past questions. You can practice those past questions. You can use study materials. We also have learning recommendation features where we can tell you specific areas that you are not doing too well. We also have very wonderful games also that you can use to help you prepare better for your jam. And to cut the long story short, it is a very wonderful app with beautiful design, wonderful UI that will help you to, for you to work hard for your JAMB exam. So we'll be looking at Surds, and one key thing we need to know about Surds is that they are irrational. So based on numbers, we have different types of numbers, as we all know, as we should know. We have integers, those are positive numbers. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have positive numbers, we have negative numbers, we have real numbers. Real numbers are the numbers that you see every day. Real numbers are the numbers that you see every day. You can see them, you can count them. So if you have money in your pocket, you know how many notes you have. I have 4 notes. You can't have -4 notes or √4 notes or square root of 4 notes. No, they are not real numbers. Real numbers are the numbers that you see every day and you can count every day. Since all of those numbers fall into two distinct categories, you can either have it as a rational number or an irrational number. And when we say a rational number is a number that can be expressed as ratios. A rational number is a number that can be expressed as ratios. If so, let me switch the screen let me put on the whiteboard so that we can see an example of that and see what we understand by that. So, like I said before, we have rational numbers and irrational numbers. So, rational numbers, rational numbers. Now, these numbers, we say that they what? They have ratios. They can be expressed as ratios. What do we mean by ratios? Something divided by something is a ratio. So let's take 1/2 is a ratio. 4/2 is a ratio. 15/5 is a ratio. They are all ratios. But once a number can be expressed as an exact ratio, that number is declared or deemed fit to be a rational number. So a very good example, or some of the examples, is the number 4, or most or all real numbers. So 5 can be represented as 25/5. That's a ratio. It can be represented as that. 7 can be represented as 49/7. 7 can be represented as 49 over 7, 21 over 3. So this, once a number can be represented by ratios, we say that that number is a rational number. But now we also have what we call irrational numbers. And these irrational numbers are numbers that cannot be represented by ratios. And that's what we have as the that's what we have as the surds. So a set of, so it's not, there are more other numbers that are irrational and they are not surds. But any number, sorry, any number that has a square root and cannot be represented as a ratio is a rational number. Take for instance root 2. Root 2 cannot be represented as a ratio. It is what? It is cannot be represented as a ratio of real numbers. So that is why root 2 is said to be what? Is said to be what? An irrational number. So you can, root 4 now can be represented as 8 over 4. So this root 4 is not a surd. It is not an irrational number. It is not an irrational number. It is a rational number because it can be represented in a ratio. Root 4 is what? 2. And 8 over 4 is what? 2. So that's just one thing. That's what makes, or one of the many characteristics of swords. And we are just going to be looking at swords, looking at how they behave, looking at the operations that they have, looking at everything about swords. And we are going to take a look at some questions at the end, and and we hope that at the end of this lecture we'll be able to clarify swords and make sure that everyone, once you see sword in the exam like this, you know exactly what to do. Okay, I'll switch back to the slides now. Okay, so we've looked at these swords, we've looked at, now operating rules of swords. So swords have a particular way that they operate, a particular way that you can operate with them. You don't just operate them the way you operate other other we don't just do their own multiplication and division the way you do other ones. No, swords have a way of operation. They have a way to operate. There's a way to go about calculate their calculations. Some things are illegal when dealing with swords. So let's look at let's switch back to the whiteboard and see some of the examples and break it down so that we can understand better. Okay, so we talked about the operations of sword. So swords, take for instance, we have root 2, we have the first one, we have root m, Just a minute. We have root mn is equals to root m times root n, and root m over n is equals to is equals to is equals to is equals to root m 1 over root n. Now, this is just a practical case. This is just how surds operate. It's just like indices where they said teaching us the laws of indices. These are the laws of surds. This is how they operate. So mind you, you can't do this. You can't say root m plus n is the same thing as, it is not, this is not equals to root m plus n. You can't say root m minus n is equals to, is not minus. Why? Because because that is not in the rule of in the laws of of sorts. So this is the laws, these are the laws of sorts. So we have to follow these laws while we are solving and going through our operations and equations. Okay, let's move on. Okay. I'm going to switch the screen back to our slides. So now we're going to be talking about addition and subtraction of similar sorts. Addition and subtraction of similar sorts. So so that's one of our, that's going to be one of our um that's one subtopic under sorts that we are going to look at. So let's start from the first ones. So let's look at the first question that we have there. So first we want to look at how to simplify sorts. How to simplify sorts. So let's take for instance, if we have a question like, if we have a sort like this, how can we simplify it to its lowest form? How can we simplify it to its lowest form? So we have root we have root 32. So we have root 32. How can we simplify root 32 to its lowest form? So if you have a surd like this, root 32. Now, mind you, 32 is also equals to 16 times 2. 32 is also equals to 16 times 2. So what we can do is that we can write this as what? 16 times 2. And what do we now move? What do we now do? We can now say, okay, let us now have 16 times 2. We can now have this 16 times 2 can also be represented as 4 square times 2. Now, once you have a surd and you can find a way, you can find a multiple, you can find factors of the number inside, that one of the factors is a perfect square. So like 16 now is a perfect square of 4. So one of the factors of 32, from the various factors of 32 that we have, that's 1, 2, there's no 3, 4, 8, 16, then 32. Out of these factors of 32, we know that 16 and 2. 16 is a perfect square. So we pick 16 out. We have 16 times 2. This 16, what is the perfect square of 16? 4. So we have 4 square. Mind you, we can also do that of what? 4 times 8. But let's continue. So this 4 now, we can now bring out the 4 to have 4 root 2, based on the fact that this 4 has a square. So because this 4 has a square, that's why we can bring out the 4 and have root 2. And like I said, we can also use 4 and 8. We can have it as what? Root 32 will be equals to root 4 times 8, which can be root 2 square times 8, which we can finally write as 2 root 8. Hope we all understand. Hope we are following. So let's move on. That's how to reduce a surd to its smallest or its simplest form. Let's take a look at another one. Okay, let's move on. Let's continue. So let's take another example. Root 72. Root 72. Now, first of all, pick the number inside. Pick the number inside and write out its multiples. So 72, we can have what? 1, 2, 3, 4, 6, 8, 9, 12, 18, 36, and then 72. Now, if you look at this, if you look at this, you will see that we can find, so the simplest form means that we need to use, the simplest form means that we need to use the simplest factor that has a perfect square. So if you look at 2, what you multiply 2, the simplest factor is 2. What you multiply 2, that will give you 72, 36. Then you check, is 36, is this a perfect square? And if it is, then you know that what? You say, okay, yes, it is a perfect square of what? 6 squared. So you now come here and now write 36 times 2. What is 36? 36 can be root 6 squared times 2. This can be written as, we can bring out the 6 out, and we have 6 root 2. Hope we understand. So the first thing you do is to what? Find the smallest factor. Check what will that smallest factor multiply. Like now in this case, the smallest factor is 1. But 72 is not a perfect square, so it's out. So the next one is 2. You check, is 36 a perfect square? Yes, 36 is a perfect square. So you know that what? Your combo is what? 36 times 2. And that is how you put your sword in its simplest form. Let's try another one before we now solve, before we now move to the addition and subtraction of similar swords. So other example, other example, other example would be root 27. Like I said again, what do? We pick out the what? Factors. The factors. So what are the factors? 1, 2, no. 2 wouldn't be a factor of 27 because 27 divided by 2 will give us a remainder. So 2 is not a factor. So 3. So 3, 9, and 27. What is our smallest? So our smallest is 1. But is 2 a perfect square? No. So we cannot use it. We remove it. The next is 27 a perfect square? No. So we cannot use it. So we remove it. But the next one is 3. What would 3 multiply that give us 27? 9. Is 9 a perfect square? Yes. Is 9 a perfect square? Yes. Perfect square. So what do we have? We know we can write this as what? 3. No. You put the perfect square first. Can write this as 9 times 3. And that will be square root of 3 square times 3. What happens? The 3 can come out. And what do you have? You have your answer to be 3 root 3. Very, very simple. Very, very simple. Very, very simple. Very, 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 very simple. This is how to put your swords in their simplest form. This is how to put your swords in their simplest form. That's another subtopic. The same swords, that would be addition and subtraction of similar swords. Addition and subtraction of similar swords. So, first question that we'll be taking is now the first thing you need to do for you to be able to add these sorts together is to put them in their simplest form. Is to put them in their what? Simplest form. Is to put them in their what? Simplest form. So now, what we can do is the first one, 32. Write out its factors. We have 1, 2, 4, 8, 16, and 32. 1, is 32 a perfect square? No. 2, is 16 a perfect square? Yes. 16 is a perfect square. 16 is a what? 16 and 2 will mean that what? Root 32 will become what? Root 16 times 2. This can be seen as what? Root 4 squared times 2, which we can write as 4 root 2. So we can come here and write 4 root 2. Plus, we do that for 72 also. So for 72, we have 1, 2, 3, 4, 6, 8, 9, 12, 18, 36, and 72. Pick the lowest one. Is 72 a perfect square? No. 2, yes. Is 36 a perfect square? Yes. 36 is a perfect square. 36 is a perfect square. So since 36 is a perfect square, we can have root 72 to be root 36 times 2, which will be what? Root 6 squared times 2, which you can write as 6 root 2. This will be 6 root 2. And we have 98. Let's just cut out. We might have to erase this one to do that for 98. So for that of 98, we know that 98 is equals to, we have 1, 2, 7, 1, 2, 7, 14, 49, and 98. We pick 2. Is 49 a perfect square? Yes, it is a perfect square. So we can have root 98 as root 49 times 2, which can be written as 7 squared times 2, which is 7 root 2 minus 7 root 2. Now, sorry about that. Now, because they all have root 2, root 2, root 2 common to every one of them, that's what makes them similar sorts. So that's why I said before you can solve like this, you need to make sure that you have put them in their simplest forms. So once you have put them in their simplest form, if anyone has -3 here, you know that you can't add that one here. So if this was if 7 root 2 was going to be 7 root 3, you know you cannot add them with it. So because of the fact that they are root 2, root 2, root 2, that is why you can have the answer. So 4 root 2 plus 6 root 2 will be 10 root 2 from our board mass. No, we do addition before subtraction. Minus 7 root 2. Then just see this as 10a minus 7a. So 10 root 2 minus 7 root 2 will give us 3 root 2. Very, very simple. Very simple. Very, very simple. So that is all about addition and subtraction of similar sorts. Let's move on. Let's see if we can do one more. Let's see if we can do one more. Um, um, let's see if we can do one more example, and then we move to the next topic. All right, let's look at another one. So we have root 12. Sorry. You have root 12 plus root 27 minus root 48. So now, first we look at 12. What are the factors of 12? We have 1, 2, 3, 4, 6, and 12. We look at 2. What would 2 multiply to give us this thing 6? So we know that what we cannot use this. Why? Because 6 is not a perfect square. 6 is not a perfect square. But look at the next one, 3 and 4. Is 4 a perfect square? Yes, perfect square. We can write this as what? 12 is equal to root 4 times 3. This can be written as root 2 squared times 3. That will be 2 root 3. So our first one that we have here is 2 root 3. If you followed us in the last one, we've solved root 27. We've simplified root 27 before as 3 root 3. Now, root 48. 48. 1, 2, 3, 4, 6, 8, 6, 8, 12, 6, 8, 12, 16, 24, and 48. So now, at 2, is 24 a perfect square? No, so we don't use 24. We pick 3. Is 16 a perfect square? Yes. So we use 16. So this will be what? Root 48 will be the same thing as root 16 times 4, which will be what? Root, sorry about the 4. Root 16 times 3, which will be, can be written as root 4 squared times 3, which is 4 root 3. So this is 4 root 3. So this 2 root 3 plus 3 root 3 is 5 root 3 minus 4 root 3, which you can write as 1 root 3, or better still, as just root 3. That's our final answer. So all you need to understand. So remember, first reduce to the simplest form. How do you reduce to the simplest form? First, you find all the factors. Then you take the smallest factor. What does the smallest factor multiply to give you the value? So look at 12 now. What does 1 multiply to give you 12? 12. But it's 12 a perfect square? No, so you don't use 12. You go to 2. What does 2 multiply to give you 12? 6. Is 6 a perfect square? No, so you don't use 6. You don't use 2. You go to 3. What does 3 multiply to give you 12? 4. Is 4 a perfect square? Yes. So you know that your combination simplest format is going to be 4 times 3, which is 2 squared times 3, which is 2 root 3. So that will be all for the addition and subtraction of similar sorts. Let's move on. Let's move on. So we are moving to multiplication of sorts. We are moving to multiplication of sorts. So if you have an example, 3 root 5 times root 20. Now, you can just do this as from what we all know. This can be written as 3 root 5 times 20 from our laws, and we just have 3 root 100. But you can still break this to a simpler form. What is 100? 100 is what? 100 has 1, 2, 4, 5, 10, 20, 20, 50, 100. 20, sorry about that. 20, 25, 50, 100. So this can be written as 3 roots. Now, like we said, 1 times 100 is 100 in perfect square, yes, but it is not in the simplest form, so we can't use that. 2, 2, 2 times 50, no? Yes, 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 yes. So you can see 1 times 100, 1 times 100. So 100 is a perfect square already. So we know this is just 10 squared. So we just have 3 times 10, and our answer is 30. Yeah, yes, 3 times 10, and our answer is 30. That's a faster way to get to where we were going. All right, guys, we can move on to another example. So the multiplication of surds is not as difficult as the addition and the simplest forms. You can just do it a very easy way. It's not as difficult as addition or other ones. Let's look at a division question. So now, if you have 10 divided by root 5, or better still, you have 10 divided by root 5. Now, to correct this situation, like in mathematics or further maths, we don't always have the situation where we have a root as the denominator. So to correct this equation, what we do is that we multiply by 1, but we multiply by 1 in a different way, which is called rationalizing. We are going to come to that, but that is the method that we are going to use. So what we just do is multiply through by root 5 over root 5. Take note, root 5 over root 5 will still give you a magnitude of 1. So it's just like we are multiplying by nothing. So root 5 over root 5 is still 1. So it's just like we are multiplying by 1. So it is still the same magnitude that it will still give us. So take for instance, so 10, this will now be 10 root 5 all over root 5 times root 5. Root 5 times root 5 will remove the roots, which will have 10 root 5 all over 5. This will cancel this. Our answer will be 2 root 5. So this is just a way, because we don't like a situation where the denominator of your ratio is a surd, because the surd is already an irrational number. So the denominator should not be a surd. The denominator should not be a surd. So what you have to do now is just to rationalize it. So you rationalize it by multiplying it by 1, but that 1 is going to be the denominator over the same denominator, just like I did here. 10 over root 5 times root 5 over root 5. This will just cancel out, and we just have our answer as 2 root 5. So if you go on your calculator, you do 10 divided by root 5, and you also do 2 times root 5, you will see that you will still have the same magnitude, the same answer for both. So it's just better to put it in this form than in this form. So thank you. So we can also look at a long algebraic multiplication. That will be our last example. So you can have something like this: 2 root 3 plus 5 into bracket 2 root 3 plus 4. So the way you do it, you can do this as 2 root 3 into bracket 2 root 3 plus 4 plus 5 into bracket 2 root 3 plus 4. So 2 root 3 times 2 root 3, you know, is 4. You know, is 2. Is 2 times 2, that's 4, times into brackets 3 times 3 plus 2 root 3 times 4 will be 8 root 3 plus 5 root 3, 5 times 2 root 3, that will be 10 root 3 plus 20. This will be 4 times, this will be 4 times 3, because it is root 3 times root 3 is 3. So 4 times 3 plus 8 root 3 plus 10 root 3 plus 20. We can have, this is 12. So 12 plus 18 root 3 plus 20. That's 18 root 3 plus 32. And that's our answer. So it's multiplication of surds is way easier than, it's just your normal multiplication, way easier than the simplification and addition of surds. But just make sure that you just multiply through. So just multiplying through, making sure that you are following the laws. You don't do anything outside the laws, you obviously get your answer. So let's move to another subtopic. Let's move to another subtopic. Let's move to another subtopic. So the subtopic that we'll be moving towards is the subtopic that we'll be moving towards is conjugate of binomial. This is very, very simple. This is what you are going to be using in your rationalization. Conjugate of binomial surds. So binomial surds means that there are more than one surd. It's not something to be confused about. So if you have, for example, 5 plus root 3, the conjugates, all you have to do is to change the sign in the middle. Change the sign in the middle. The conjugate will be 5 minus root 3. That's all. That's the conjugate of the binomial surd. The conjugate will be 5 minus root 3. So you have another example. If you have another example, if you have another example, 3 root 5 plus 2 root 3, the conjugate will be 3 root 5 minus 2 root 3. All you have to do is change the sign inside. So even if it was a situation where you had negative inside, so let's look at another example. All you have to do is just change the sign inside to the opposite sign. So if you have another example like this, you have 3 root 2 minus 2 root 5. All you have to do is what? The conjugate would be 3 root 2 plus, sorry about that, plus 2 root 5. So it's just very simple. Just the conjugate is just very simple. It's not a very a confusing subtopic. It's not a confusing subtopic. All right, so let's move to our next subtopic. Let's move to the next subtopic. Let's move to the next subtopic. Okay. So the next subtopic will be, so like the first one we choose was the rationalization. I've shown the rationalization of the normal surds. So what we are going to be looking at now, is now the rationalization of the binomial surds. Rationalization of the binomial surds. Okay, let's move on. So let's say you have 3 root 5 minus, sorry about that, 3 root 5 minus 2 all over, I want to write it again. So we have 3 minus 2 all over 3 root 5 plus 2. Now, this is a situation where we want to rationalize these surds, these binomial surds. Like I said, when you have a surd in the denominator, whether it's solely standalone, we don't like a situation like that in mathematics. So we always want to change that situation. So what we have to do is just to multiply this. Let me put that in another mark ink. All we have to do is to multiply this by the conjugate. And what will the conjugate be? The conjugate will just be plus. The conjugate will not be plus. Why? Because there's already a plus here. So the conjugate will just be multiplying by what? Negative. So the conjugate of the denominator. Note, conjugate, sorry, conjugate of the denominator. Conjugate of the denominator. So how do we multiply this? This is quite easy. 3 root 5 times 3 root 5. We know how you normally multiply. So this will just be, the numerator will just be 3 root 5 into bracket 3 root 5 minus 2 minus 2 into bracket 3 root 5 minus 2. Now, this denominator is, there's an easier way to do it. From our elementary maths, we know that a minus b into bracket a plus b is the same thing as a square minus b square. A minus b into bracket a plus b is the same thing as a square minus b square, and that's the same situation that we have here. 325 as our a plus 2 as our b times 325 as our a minus 325 minus 2 as our b. So all we just need to put as denominator is 3 squared minus 2 squared. So we can finish this off. 3 root 5 times 3 root 5, like we know, the root 5 will multiply the root 5 to give us 5. So root 5 times 5 is 5. 3 times 3 is 9. So we have 9 times 5, and that's what? 45. 3 root 5 times minus 2, that will be minus 6 root 5. Minus 6 root 5 on the other side, plus 4. All over 3 root 5 squared will be 45. Yes, because we already did this here. 3 squared times 5. 5 squared is what? 5. So 3 squared times 5, that's what? 45 minus 4. So what do we have? We have 45 plus 4, that's 49, minus 6 root 5 minus 6 root 5, that's what? 12 root 5, everything all over 41. And we have our answer. We have our answer. It's not something that is going to be difficult. It's practically easy. All you need to make sure that you do is that you don't forget to use the conjugate. You don't forget to use the conjugate. Because if you don't use the conjugate, you end up still having a denominator below. And after rationalizing, there must not be, the point of rationalizing is so that there is no surd as a denominator. The point of rationalization is so that there is no surd as a denominator. The point of rationalization is so that there is no surd as a denominator. Hope we got that. Hope we understand that. So we've gone through all of the major topics, subtopics in swords. So we've gone through the addition of similar swords. We've gone through what a sword is. We've gone through all that. So let's just take a look at some questions in the EdSofta app. Let's take a look at some questions in the EdSofta app. So I'll be sharing my screen. So what we have here is an EdSofta app. So this is what it looks like. For those that have the desktop, this is what it looks like. But we also have the Android. The Android still looks a bit like this, but just on a smaller screen. So um, you can decide to, let's just talk about a few features. You can decide to put it in the light mode, depending on what you like to use. But let's use the dark mode. So while we were on the break, I took the pain of going through some of the questions here and just picking out a few. So I went to the questions here. I went to mathematics, and the swords is actually under the theme number enumeration. So I've done this. So I already picked some questions. So you might not really need to go and look at a test. So I picked some questions and I saved them. So we're just going to be looking at these questions. So you see, you can save some of the questions. Let me just open the practice um, view so you can see it. I'm just open the practice view so you can see it. So this is exactly what the practice looks like. This is what the practice looks like. So you can decide to save a question. You can see question saved. So then you can log out if you are no more interested. So now going back, we can now go to saved questions. As I have already said, we'll choose a mathematics. So I already saved some of the questions that I want us to take. So one of them will be in 2014. So look, simplify, and like I said before, what is to rationalize. So you can see we also have explanations here. So if you look at, if you can see this, let me see if I can zoom. Let me zoom. You know, solve it. So the question is, so let me just see if I can. I may not be able to zoom in on the app, but let me write the question out. So they said we should simplify this. So like we said, what you have to do is what? Just multiply by the what? Conjugate. Multiply by the what? Conjugate of the denominator. Please do not forget. So what you have is 2. When you multiply this, you have 2 into bracket 2 minus 6 minus root 6 minus minus 3. Yes, because you have root 3 times 3. Root 3 times root 3. That would be what? 2 root 2 times root 2 is 2 into bracket 2. 2 root 2 times minus root will give us minus 2 root 6. Minus root 3 times root 2 will give us root 6. minus root 3 times minus root 3 will give us plus 3. So all over, like we said this is always going to be what? That's our A minus B into bracket A plus B minus B squared. So this is root 2 squared minus root 3 squared, which you can write as this will be 4 plus 3 minus 3 root 6 all over 4 minus 3 and sorry all over 2 minus 3, and what do we have? We have 7 minus 3 root 6 all over minus 1. This we can write this this is minus 1 that is here, just to remove the all we just need to do. Sorry. Sorry about that. I expected my whiteboard to be sharing. So all we just need to do is flip. So if you followed me from what I was saying, 2 root 2 minus root 3 all over root 2 plus 3 all over root 2 plus 3 we have times. So like I said, you multiply by the conjugate of of you multiply by the conjugate of the the denominator. So when you have 2 root 2 minus 2 root 6 minus root 6 plus 3, so when we did the multiplication, and if you can remember, I said this 2 root 2 plus root 3 times root 2 minus root 3 is still the same thing. So we can just have a squared minus b squared here also. So we can just have root 2 squared minus root 3 squared, if we understand what I mean. So this will be 4 plus 3 minus 3 root 6 all over 2 minus 3. So now here, here, this minus 1, we can just remove it by changing the sign here. So we just have 3 root 6 minus 7. Minus 7. And that's all. That would be all. That would be all. That would be all. So we've majority of the questions on rationalization on Surds are usually about the rationalization, and the rationalization is not very hard. All you have to do is multiply by the conjugate of the denominator all over the same conjugate of the denominator. By the time you are done with your multiplication, you will see that you have gotten the value for the answer in the option. So I'm just going to look at some other questions in the app. So I may not really solve, but look at some other questions, talk about how they solve it, then we can call it um, a class, while in the next 15 minutes we'll also start the new, that will be around 5. We'll start the we'll start another set. Okay, let's look at some other questions. I also saw another question in 2011. So this is a multiplication question, and we've done multiplication. So all you have to do is root 2 times root 2, root 2 times. So you just break it the way you do your normal algebra multiplication. The if you can see the explanation here, the explanation here is quite okay. Then the other questions we have 2015 also. Now this I would love to solve. This I would love to solve. So let's look at this question. So I'll be sharing the whiteboard. Okay. So this is on the last. So first, we have to first because we have to first put it in its simplest form. So let's look at 147. We have 1, 7 to 21, 49, and 147. Very simple. 3 and 49 because 49 is a what? Is a perfect square. So we can write this as 147 is equals to root 49 times 3, which is root 7 squared times 3, which is 7 root 3. So this can come off as 7 root 3 minus, so 75. 75 will be 1, 3, 5, 15, 25, 75. Very simple. 25 perfect square and 3. So you can come off as 75 is equals to root 7 squared. Sorry. Come off as 25 times 3, which is root 5 squared times 3, which can be 5 root 3. But now we also need root 48, and we've done root 48. If you've been following, it can come off as 16 times 3, which can come up as 4 root 3. So this can come off as 5 root 3 all over 4 root 3. This will be 2 root 3 all over 4 root 3. This will cancel this will cancel this. We have half as our answer. Hope it's I hope it's we understand. I hope we understand. I hope we understand. So you can come up as half. So our answer is half. So swords a very interesting and easy topic, something that we can all do, something that we should understand by now. We would be coming back by around 5:10, where we will be taking another topic, which is circle geometry. So thank you very much, and God bless you.